Hello everyone, you are all welcome to today's presentation about learning theories in mathematics. I hope you will enjoy the presentation. Learning theories. Learning theories are conceptual frameworks describing how information is absorbed, processed, and retained during learning. Cognitive, emotional, and environmental influences, as well as prior experience, all play a part in how understanding or a worldview is acquired or changed, knowledge and skills retained. On our right hand side, you can see a classroom in Norway. This is a classroom setting and showing us that learning also takes place in many other settings apart from the normal classroom settings we used to know of or we have in our various localities. Theories of learning mathematics. According to mathematics education, there are four main theories in the learning of mathematics. These theories are as follows: behaviorism, cognitivism, constructivism, and the developmentalists. Now, in this presentation, we are going to concentrate on the constructivism view of learning mathematics as propounded by Jean Piaget. Piaget's stage theory and learning mathematics. Piaget was a biologist and a psychologist. His interest was in the physical structures that characterized organisms and that of the structures of thinking of children. Through this technique, he became convinced that certain basic structures of thinking, which can be described as logical or mathematical, are inherent in human beings. His work emphasized on the stages of development, which are 1. Formation of mental concepts, 2. Adaptation of concepts, and 3. Relating the concepts to form a network. Again, on the right hand side, we can see a photograph of Jean Piaget, and it was taken around 1962 when he was conducting his experiments on his stage theory. Piaget and cognitive development. Cognitive development is parallel to physical development as it develops in stages. Piaget in the year 1962 proposed 4 stages of cognitive development as shown in the cognitive development stages diagram below. The first stage, which is sensory motor period, and the second stage, which is pre-operational period, third stage, period of concrete operations, and the fourth stage, period of formal operations. Talking about the sensory motor or the psychomotor period, this begins or starts from birth to the age 2, as we can see in the chart or diagram. The second stage, which is the pre-operational period, also begins from year 2 and ends year 7 as shown in the diagram. The third, which is period of concrete operations, also starts from year 7 to year 11, and the fourth stage, that's the period of formal operations, also begins at year 11 till adulthood, or let's say during one's adolescence adulthood, or from adolescence to adulthood as shown in the chart. The sensory motor or psychomotor period. The sensory motor stage is the first stage of the 4 stages in cognitive development, which extends from birth to the acquisition of language. In this stage, infants progressively construct knowledge and understanding of the world by coordinating experiences such as vision and hearing with physical interactions with objects such as grasping, sucking, and stepping. Infants gain knowledge of the world from the physical actions they perform with it or within it. They progress from reflective instinctual action at birth to the beginning of symbolic thought toward the end of the stage. Now, children learn that they are separate from the environment. They can think about aspects of the environment even though they may be outside the reach of the child's senses. In this stage, according to Piaget, the development of object permanence is one of the most important accomplishments. Object permanence is a child's understanding that objects continue to exist even though he or she cannot see them or hear them. Again, on the right hand side, we can see a nice picture depicting two professional nurses and a child. We can see that the nurse covers her face with her hands, but the child stretches his hand to find whether the spectacle he saw at first still exists. And as the nurse removes her hand, the child will confirm that yes, or truly, that object which is her spectacle is permanent. This is called a simple peekaboo test, which is good for determining whether children in the sensory motor stage has acquired object permanence. After this, we are going to watch a short video showing Piaget's experience in explaining what happens at the sensory or psychomotor period.
Or, ça n'est jamais une copie. Elle est toujours une assimilation, c'est-à-dire une interprétation par intégration de l'objet dans des structures antérieures du sujet. Le meilleur exemple qu'on puisse donner pour justifier cette thèse, c'est l'étude du dessin lui-même chez l'enfant, étant donné que le dessin, par définition, est une copie d'un modèle. Eh bien, ce qu'on observe chez le jeune enfant, c'est que l'enfant ne dessine pas ce qu'il voit. Une petite fille nommée Emmanuelle qui a 3 ans, 6 mois, et qui va copier devant vous un triangle.
Take a good look at it, huh?
Like that.
Like that?
And then the corners here.
Little what?
Little point here, see?
Ah, yes.
Ce triangle, elle le conçoit comme une sorte de carré auquel elle rajoute 3 pointes. Des pointes qui sont d'ailleurs arrondies et pas pointues, mais qui représentent dans son esprit, elle le dit, 3 pointes.
The pre-operational period. Piaget described an operation as an internalized action that includes reversibility actions. Perception of quantifiable quantities lead to distortion, yet children at the early stage of this period are dominated by perceptual influence and so find it difficult to do the following. 1. Match objects in one-to-one correspondence, and hence they are not ready to be taught number relations and quantities. 2. they find it difficult to see the constancy of length, weight, matter and number. 3. They use observations and experimental methods in problem solving rather than logical reasoning. So on the right hand side, we can see a child within the ages of 2 to 7 trying to solve a problem given to him, and we can see him experimenting with the objects that he's supposed to use, and he can't reason logically at that stage, so he tries to use experiments or try and error just to cater for the solving of that problem. But a short video will be displayed showing Piaget's explanation as to how children are not able to use or see the constancy of length, weight, matter and number.
Say it's the ocean, this blue cardboard? Huh? We'll say it's the ocean. You know the ocean? Have you ever seen the ocean? And in the ocean we put some islands. There are islands.
Oh, yes.
Okay?
Yes. A big one.
A big one, yes. And on one island we built a house. You see, it just fits on the island. It's built on the whole island, but it doesn't go off it. Now, what I'd like for you, with these blocks, you build a house too on that island here. On the whole island, huh? But without going off it, huh? And I'd like that house to have just as much room as this one here.
Okay.
Do you understand? Just as much room as in this one. Just as much. Okay? Go ahead.
You can't put any more.
Yes, that's fine.
There.
It's the same house? There's just as much room in the two houses?
Yes.
You're sure? How do you know?
Because I see.
How do you see? You can lift that one if it helps you. You can pick it up. Show me. I don't see very well. Yes. I didn't mean like that.
Okay.
But show me how you see there's just as much room in the two houses.
Because I see they're just this big.
And if they're just as big, like that, there's just as much room in them?
Yeah.
You're sure?
Yes.
Vous constatez donc que le plus jeune, à 4 ans, n'a aucune idée du volume. Il a beau comprendre qu'on lui demande de faire une maison qui contient la même place, la même chose de place, comme nous disons en français enfantin, eh bien, il cherche simplement une maison de même hauteur.
The concrete operational period. In this stage, which follows the pre-operational stage, occurs between the ages of 7 and 11, that's the pre-adolescence years, and is characterized by the appropriate use of logic. During this stage, a child's thought processes become more mature and adult-like. They start solving problems in a more logical fashion. Abstract hypothetical thinking is not yet developed in the child, and children can only solve problems that apply to concrete events or objects. Piaget determined that children are able to incorporate inductive reasoning. Inductive reasoning involves drawing inferences from observations in order to make a generalization. Once again, on the right hand side, we can see a chart or diagram representing the various aspects or various thinking processes that forms the concrete operations. Starting from the green section, we can see seriation followed by classification, reversibility, conservation, decentering, and what? transitivity, and all these processes acquired forms the concrete operations. The formal operational period. The final stage is known as the formal operational period or stage, which is adolescence and into adulthood, roughly ages 11 to approximately 15 to 20. Intelligence is demonstrated through the logical use of symbols related to abstract concepts. These form the thoughts includes assumptions that have no necessary relation to reality. At this point, the person is capable of hypothetical and deductive reasoning. During this time, people develop the ability to think about abstract concepts. Piaget stated that hypothetical deductive reasoning becomes important during the formal operational stage. This type of thinking involves hypothetical what-if situations that are not always rooted in reality. For example, counterfactual thinking. It is often required in science and mathematics. Moving to the right hand side of this slide, we can see a chart talking about various aspects of formal operations. Starting from the pink circle, we can see that children start to test hypotheses, and after they have hypothesized or hypothesizing issues, they try to make what? Deductions. So when these three stages or cycles are being achieved, we can confirm that the child is now in the what? Formal operations period. Now, there will be a short video showing how children within the formal operational period use hypothetical deductive reasoning to make what? Generalizations or to make deductions.
What are you counting?
I'm counting so it has the same volume.
Yes, but explain what you count each time.
There has to be 4 times 9 cubes to make that.
4 times 9 cubes, because 9 cubes, what does that represent?
Well, the surface of that.
A slice. Yes, show me the slice. All right, all the way around.
And then there have to be 4 to make the whole building.
Good, so go ahead.
Enfin, la jeune Popov, 12 ans, découpe le volume en tranches et met ces tranches en relation avec les étages. Et elle se livre ainsi non seulement à une quantification numérique, c'est-à-dire de la mesure, mais elle procède à une multiplication. 9 par tranche, 4 étages, ça fait 36 plots pour donner le même volume. Le problème est donc résolu, et comme vous voyez, il a été résolu par des étapes qu'il est facile de caractériser, et étapes que nous retrouvons d'une manière très générale partout où nous étudions cette même épreuve avec la même technique.
You count 3 times 4. Is that it?
Yeah.
Le premier fait frappant dans le développement des connaissances, c'est évidemment leur créativité continuelle. À voir tout ce que le bébé, avant le langage, pendant les 18 premiers mois de l'existence, arrive à construire dans le domaine de l'objet permanent, de l'espace, du temps, de la causalité, etc., on est stupéfait de ce nombre de constructions spontanées qui ne sont évidemment pas dictées par l'adulte. De même, la construction des structures opératoires dont nous avons parlé tout à l'heure.
Hope you enjoyed the video. Now, let's continue with some terms which are associated with the formal operational period. 1. Abstract thought. This emerges during the formal operational state. Children tend to think very concretely and specifically in earlier stages and begin to consider possible outcomes and consequences of actions. 2. Metacognition. This is the capacity for thinking about thinking that allows adolescents and adults to reason about their thought processes and monitor them. Problem solving. This is demonstrated when children use trial and error to solve problems. The ability to systematically solve a problem in a logical and methodical way emerges. 4. While children in primary school years mostly use inductive reasoning, drawing general conclusions from personal experiences and specific facts, adolescents become capable of deductive reasoning, in which they draw specific conclusions from abstract concepts using logic. This capability results from their capacity to think hypothetically. Implications of Piaget's theory in child education. Now, why should we be concerned about implications of Piaget's theory here in child education or in mathematics education? Let's consider 3 reasons. 1. Essentially, Piaget's work shows that children cannot learn like adults. They lack the essential mental constructs, namely the reversibility of thought and inclusion relation, which cannot be taught by external means only. 2. His claim that the stages are biologically based, so that no amount of teaching can accelerate learning, suggests that every child must pass through the same learning processes. 3. This claim, however, no longer holds, since researchers consistently show that learning can be accelerated. All the same, child educators or mathematics educators must be cautious, as there are varied implications of the stages in mathematical teaching and learning. This brings us to the end of today's presentation. Well, thank you for watching. Until we meet again, it's a goodbye. Hope to see you soon. End of presentation.